What is cosine? No. It was like they gave you an angle and then a side line, and they said find this side. It was one, I guess.
Did you get it right?
No.
All right. Now you can, though. Okay, objective. Today we're going to talk about right triangle trigonometry. And it should be pretty easy, okay? All right, so it's just right triangle. So when you see these up here, sine, cosine, tangent, this only works for right triangles, okay? Only works for right triangles, only. This stuff only works for right triangles, does not work for any other triangle, but only. Right triangles. This week, no, I'm sorry, next week we'll talk about triangles that are not right triangles, and there's formulas for those too. So sine, before we do anything, let's just real briefly put theta. Theta is simple for angle. Theta is my angle. Theta is my angle. Theta, it's a Greek letter, that's all. Theta, and it's for us, it just means angle, okay? So it depends on where the angle is. This particular angle is here. Therefore, this is my opposite side. Throw the rock to the opposite side. My adjacent side. And of course the hypotenuse. Hypotenuse because it's the longest side. Yeah. What I know about sine, it's a ratio. And I want you to understand this, okay? It's really important you know why it works, okay? All right, it is important, okay? Now watch. We create an invisible triangle. See the invisible triangle created? So as the angle changes, so does the opposite side, correct? And believe it or not, so does this side here, right? Because to make the triangle, right? So there's three things going on. When you change the angle, three things. You've got two sides at an angle that all work together, right? And that's why they're all together up there. So the sine of an angle is just looking at the ratio between the opposite side and the hypotenuse. That's all. Opposite side and the hypotenuse. As one changes, it changes the other two, correct? I mean, if the side changes, it changes the other side and changes the angle, okay? Cosine is just a relationship or a ratio between the opposite or the adjacent side and the hypotenuse. The tangent is just a ratio between the opposite side and the adjacent side. As one changes, the other two changes. You change the angle, then the adjacent side changes, okay? Now these three no one really uses, but in math they can happen. All that cosecant is it's the opposite of this one. So cosecant is really the 1 over the sine, it's the inverse, which is the same as the hypotenuse over the opposite, okay? Now we won't use this much, but it's still a math term. The secant is the opposite of cosine. So the secant is really 1 over the cosine of theta, which it makes the relationship of the hypotenuse over the adjacent side, okay? And the cotangent is the inverse of the tangent, so it's 1 over the tangent, which is the same thing as the adjacent side over the opposite side, okay? Pretty easy, right? So let's look at example 1. Am I going too fast or am I doing okay? Okay, now, find all 6 trigonometry ratios. Now the ratios just mean we want the fractions only. That's what we want, the fraction. Don't solve it, we just want the fraction. Ratio is a word meaning fraction, okay? So I need the sine of theta. I'm going to need the cosine of theta. I want to find the tangent of theta. And I need the cosecant of theta, the secant of theta, and the cotangent of theta, okay? Well, what's really nice is to label the triangle before I even start, because it gets really easy. So, for example, here's my angle, 12 is my opposite side, my 5 is my adjacent side, and 13 is the hypotenuse, right?
When finding like each side, is the adjacent always the one on the bottom?
No, great question. Really good question. Thank you for asking that. So if Vincent, you stood here, then that's the opposite side.
Oh, okay.
Because you're going to throw a rock to the opposite side of the lake, right? And if this is the opposite side, then this becomes the adjacent, that's the one next to you. Really good question, because that'll mess you up.
Yeah.
You have to ask these questions, you guys, because if you don't get it right, then you messed up the whole thing, right?
So wherever the little circle is, that's where the adjacent side's gonna be?
Right, except for,
right.
except for the hypotenuse already has it,
Yeah.
right? Yeah, totally right. So if this is the angle you want to work at, this side's next to you, adjacent, and this side's the opposite of you. Yes, Ellie?
So do you ever have problems with that theta at the 90-degree angle because then the hypotenuse and offset are the same?
You won't in right triangle trig, no. However, we're going to take a look at some problems where it can happen with the law of sines or the law of cosines. But we'll learn that Tuesday, Wednesday, Thursday, okay? Good question. We will look at the 90, but not with right triangle trig. It will, you never, so never use the 90, okay? Never. Okay, so the sine, let's see, if I'm going to do the sine is opposite over hypotenuse, right? And again, it's up there on the wall in blue, which helps you if you guys. So opposite over hypotenuse is just 12 over 13, right? Okay, help me out. What's the cosine?
5 over 13?
Yep, perfect. What's the tangent?
12 over 5.
Yep, perfect. What's the cosecant?
13 over 12.
Yep. Secant? Yep. Cotangent? Easy. Thumbs up?
C.
Good. I mean, we're going to hit something pretty easy. This next week should be a lot easier than some of the other things we've done, okay? Now, example 2. So it says find the length of AB. So AB, I just like to use a variable. I got to leave it as AB. Want to call it X? Actually, we should call it C. Technically, it's C because here's angle C, side C. So AB is technically C. So we label our angles as capital letters. Angle A, angle B, angle C, and then the sides. This would be side B, a little b, right? So we label them as small. This is little b. This is little a, and this is little c. Okay. That's how we label. So instead of A, let's just call it C. Go with that. Oh, what a mess. Well, anyway, it's Friday. It's been a Friday, huh? Yeah. Exactly. So here's what I do. So here's how you do it. Go to the angle first. Always start with the angle. Always start with the angle. Always start with the angle. So I'm at 34 degrees, right? And then after I start with the angle, then let's figure out what these sides are. The 5 is my opposite side. Little a is my adjacent side. And little c is my hypotenuse. Okay, everybody good with that? I don't care about the adjacent. It's not in the question, correct? The question doesn't ask anything about CV, so I don't care about the adjacent. It doesn't really matter. But what are the two sides I'm concerned with? The opposite and the hypotenuse. So I'm looking for one of the trig functions that has opposite and hypotenuse in it. Okay, so look up there. Opposite hypotenuse, which one does it have to be? Yeah, it's going to be sine. Sine's the only one up there that has both opposite and hypotenuse up there. We don't care about the adjacent. It's not asked. We don't care about it at all. So let's use sine because sine is the opposite over the hypotenuse. Okay, thumbs up. So instead of writing theta, theta represents an angle. So I'm going to put 34 there. I'm going to put 5 there, and I'll put C here. Okay, so I'll rewrite this as sine 34 degrees equals 5 over C. So I just replaced theta is an angle. It's a 34-degree angle. I've got my opposites 5 and c. So I want to solve for c. And so I'm just going to multiply up by c. So I'm going to times up the c. I'll bring it up here. Times c. So I'll go c times the sine of 34 degrees is equal to 5. I want to solve for c, so the first thing I do is multiply it up. Okay, everybody good at that? Now, sine of 34 is a number. It's on our calculator. So it is a number, so I'm just going to divide by sine of 34, divide by sine of 34, and I'm just going to use my calculator now. One thing real quick, in my mode, I just pushed my mode button.
Degree.
Yeah, it is degrees, 34 degrees, right? Degrees, make sure you're in degrees, not radians. Same thing if you use your cell phone, make sure you're in the right mode, otherwise you get the wrong answer always, okay? So I'm just going to type it in just like it says. Quit. I'm just going to go clear, let's go 5 divided by sine of 34, close the parentheses, and I get about an 8.9, okay? 8.9, okay? Now, I always think it's worthwhile also to check for understanding, question mark, question mark, question mark. 8.9? Yeah, it seems reasonable, doesn't it? Does that seem reasonable? Okay, good. Centimeters. Thumbs up. You guys remember how to do this from last year? Maybe? Okay, turn the page. Okay, now, theta. So, anytime you want to find an angle, so to find an angle, you have to use this. To find an unknown angle. You're going to push either, and they're in blue, sine inverse or cosine inverse or tangent inverse. Okay, so in my calculator, the buttons I want to push are going to be in blue, in blue, in blue. It's the inverse. We're saying to find an angle from a side versus from a side to find. Okay, so let's see. If I go to my triangle, here's my angle, right? Always go to the angle. My 8 is on my opposite side, and my 10 is my adjacent. I don't know anything about the hypotenuse. I don't care. Hypotenuse is irrelevant. So, opposite adjacent. So I look up on the board, and which one should I use? Right, so I'm going to write tangent theta equals the opposite over the adjacent. All right. So let's put some numbers in. The opposite is 8, and the adjacent is 10. Let's put the numbers in. So I'll go tangent of theta is equal to the 8 over the 10, right? So now I'm going to use this button here. I'm going to use the inverse button. So I'm going to rewrite this as tangent inverse of 8 divided by 10 equals theta. So I just use my calculator. It's in blue. Second tan. 8 divided by 10, close parentheses. And I should get a 38.66. Okay, everybody try it. 38.66. Make sure everybody gets the answer. Okay, thumbs up, everybody. Make sure you get it. I want to make sure everybody gets it, okay? Good. Good. All right. It's super easy, isn't it? Okay. So then, everybody get that answer? All right, now let's take a look at example 3. So example 3, we're going to solve. There's a right angle here. Just got hole punched out. There's a right angle, you guys. Just got a hole punched out, okay? So now, this example 3 says find all the missing sides and angles. So I've got 3 things to find. I need to find angle A. I need to find angle I. I need to find side P and side I. Okay, I got to find all three of those, okay? All right, what seems like the easiest to find? If I look up there, what do you think is the easiest thing to find?
Angle.
Angle I, everybody agree? So there's two ways to find it. The hard way is you add them up, subtract from 180. That's the hard way, okay? Seriously, the hard way is 90 plus 68 minus 180. However, you always know these two always have to add up to what?
90.
Right, so that's the fast one, 90 minus that, right? You guys agree with that? Yeah, that's the easy way. So just go angle P, or angle I, sorry, angle I, we'll just go 90 degrees minus 68 degrees, and I'll get, I don't know, what's that? Is that 22? 22. So I'll put 22 in here, okay? Now you get two choices. I don't care. You can either find little p or little I, okay? So, Greer, what do you want to find? Little p or little I? It does not matter.
Little I.
Little I, okay? Vince, it doesn't matter. Do you want to use 22-degree angle or 68? It does not matter.
Do 68.
68, okay? So now, once you've done that, you've established cosine. Now, why do I say that? You've forced yourself into cosine. Why? Yes, Ellie?
Because you have to use the known side, which is the hypotenuse.
That's-
And trying to find the adjacent.
Good, good. See what she said? I forced you to use cosine. Actually, it was Greer and Vince that forced you to use cosine, right? Because you know the hypotenuse. You want to find the adjacent. You don't care about this side yet. Okay, so let's use cosine. Cosine of theta is equal to the adjacent over the hypotenuse, right? Or cosine of 68 degrees equals the adjacent, which is little I, over the hypotenuse, which is 13. Okay, and I'll slow down for a second, okay? How do you solve for I? It's really easy. Yes, Ellie?
Multiply everything with it.
Yeah, just multiply everything by 13, or I'll just cheat and bring 13 up here, okay? So, little I is equal to 13 times the cosine of 68 degrees. Just use your calculator, right? 13 cosine 68, and I get an answer of about 4.87. 4.87. Let me put that in there. 4.87. 4.87. Okay, good. Now I've got one more thing to find, and that's P. So, you've got two choices. I don't care how you solve it. You could, you guys ready? You could go a squared plus b squared equals c squared, right? You could, that works. Or you could use sine. They both work. What do you like? Pythagoras theorem, or do you like sine? Right? I like the sine, it's shorter. But if you like Pythagoras theorem better, use it. They both work, right? I like sine because it's shorter. I'm going to just go sine. I'm going to go sine of 68 is equal to little p over 13. That's the way I'm going to solve it because it's faster for me. 13 times, that's a 13 out of b. 13 times sine of 68 equals a little p. And so 13 sine 68, I get an answer of about 12.05. Or use Pythagoras theorem to get the same answer, okay? What do you think? Pretty easy? Okay, I'll give you a second to do that. Vince, you're typing them in, right? Okay. And then number 4 is our hot air balloon, right? This really is our hot air balloon problem. We got a 6-foot man sights the top of a building at an angle of elevation of 65 degrees. If the man is 50 feet from the base of the building, what's the height of the building? Okay, so I'm going to draw a picture because picture always helps. The triangle we're going to draw is actually suspended, isn't it, by 6 feet. So the triangle I'm going to draw is going to be right here. When I get done, I'm going to add in the 6 feet, right? Plus 6 when I get done. add the 6 feet when I get done. So, what do I have? Well, I want the height of the building, call that H for height. I know this is 50. My angle is 65 degrees. What am I going to use? Who said that? Tangent. Good job, Ellie. I want to find my opposite side. I know my adjacent side has to be tangent. Everybody agree? So tan of 65 degrees is equal to H over 50, opposite over adjacent, multiplied by the 50, tan 65 equals H. Everybody agree with that? I'm going to go 50 tangent 65. So I get 107.23. So I get 107.23, but I have to add in the 6 feet, right? You guys agree with that? 113.23 feet. What do you think? Easy? All right. So the homework assignment's there. I think we can get it done. I do want to talk about that reverse egg drop